Hello and welcome back to our series on applying machine learning to a real-world dataset. Our goal is to prepare this dataset to feed into a variety of machine learning algorithms. In today's episode, we address the topic of standardization. So why do we standardize data? Well, let me do that with an example. If I wanted to develop a universal score for how good a footballer is, I could just sum all the statistics that I have on them. Let's say I only have two stats, the average goals scored and average minutes played, both per match. Could I just sum them together? Well, no, not really. Minutes played will range from around 60 to 90, and goals scored, well, they might range from around 0 to maybe 0.4 per match. If I just sum them together, goals scored will be an almost insignificant part of things. My universal score will mostly be determined by minutes played. And we can see here now, player 2 has a much higher universal score, even though he scores much less than player 4. And that just doesn't feel right. If I instead standardize both of the numbers, subtract the mean from each score, and then divide by standard deviations, then I get a value that shows how much different this player's statistic is compared to all players. And both statistics are shown in the same units, i.e. standard deviations away from the mean. Now being scaled to the same units, I can add them without one overpowering the other. And we can see that player 4 is now scored higher than player 2. So how do we standardize? Well, the first thing we need to do is remove our only non-numeric column, which is record type here. This is an index, it doesn't count. So I'm going to clear this out, and then we'll create a new row. We'll give it some markup. We will call it add red flag column. Let's just run all to clear that old result set. Okay, so I'm going to drop the record type column, and I will do this in a new data frame. I'll call df issues standard. And to do that, df issues.drop, command we have used a few times before, record type. And I want to do this on axis equals 1. And once we've dropped out that non-numeric column, we can use scikit-learn's pre-processing standard scaler to actually do all the standardization work for us. To do that, though, we do need to add it up at the top here. And that is from scikit-learn.preprocessing import the standard scaler. Now we can go back down to our code here, and we can create an instance of it, and that will, I'll just call it scalar equals standard scalar, and we use this to standardize all the numbers in our new data frame, and that is df issues standard will equal a new pandas data frame. We use our scalar, and we use its fit function. Actually, we use its fit transform function. That will fit it and transform it for us. And what are we doing it to? Well, we're doing it to df issues standard. I'm going to pipe df issues standard into this, and out of it we will get a new data frame that is the result all standardized. Now this will actually produce an array output, a numeric Python array, and that will not have any column names. So I should go back here, and before we're finished, I should tell it what our column names need to be. And that is simply a list of all the column names from our original df issues standard. So that's df issues standard dot columns dot values. Close that off and close that off. And we'll also need to add back our index. That will now be missing. So we'll go to df issues standard dot index. And this will be the same index as we have on df issues. Let's take a look at what we have so far. df issues, cell, run all. Oops, that's df issues. I want to look at df issues standard. Let me copy that while it's thinking. and cell run all. It talked to us a little bit about what it's done there, with some conversion warnings and things that we don't need to worry about too much. And here we have all of our data now standardized. We do have one problem here. Our red flag column was standardized as well, and that isn't supposed to be scaled. It's supposed to be either a 0 or a 1. We could have written a custom scaler to ignore that particular column, but it's actually less typing to just fix it after we wrongly scaled it here. So what we first need to do is find the max value. That would represent all the ones. They got converted into 3.41, etc. And all our zeros got converted into negative 0.293, etc. So first we'll formally find the maximum value, and that represents the ones in our set. And then we'll take that value and we'll create a mask and say get a mask of all these rows so that we can set them to ones. We'll call this RF mask for red flag mask equals df issues standard. Get that out of our way there so it doesn't bother us in future. So df issues standard red flag, and I want this wherever red flag issues, so that's df issues standard, wherever this red flag value happens to equal the max red flag value. And the next thing I'll do is set all of these red flag values to 0. And then I'll use the mask to update any that met this criteria back to 1. So df issues standard red flag equals 0. And then df issues standard dot lock RF mask. And wherever that's true, set red flag equal to 1. Now let's see what we have. And I used an equal sign there when I should have used a double equal sign. Okay, there are our warnings. What did I do wrong here? df issues standard.lock RE mask. It should be RF mask. Okay, no errors this time, and let's check out that red flag column. It's all zeros and ones now, just like it should be. Now that wraps up our data set for machine learning. At this point, we're ready to launch in several different directions. Neural networks, support vector machines, or classifiers, other fun things. I'll be starting on those very soon, so click subscribe to stay up to date with our latest videos. Thanks for watching. Bye.